Hi everyone, my name is Umang Kumar and I am from HPE. Today we'll be discussing about demystifying edge devices, cloud native storage for different data sources. Along with me, this paper has been co-authored by Subhadip and Chaitra S. They are also from HPE. Today I'll be taking you through the entire presentation. So let me go to the next slide. 5G will be driving new digital revolution in terms of speed, scale, and stability for edge. It is going to drive new use cases at the edge, which we will discuss later. If you compare key statistics between 4G and 5G, we are talking about peak data rate, which is 100 times faster than 4G. We are talking about latency, which is almost 50 times slower than or lesser than 4G. We are talking about connection density, which is 50 times more than 4G. With theoretical peak data rates up to 100 times faster than current 4G networks, 5G holds the promise of enabling incredible new applications and use cases such as autonomous vehicles, telemedicine, and the ability to share and potentially life-saving resolution, real-time medical imaging, just to name a few. The global volume of zettabytes data generated annually is projected to triple between 20 and 25, according to IDC report. And 5G is going to be the biggest contributor. Let me go to the next slide. So 5G will be bringing different new use cases that will lead to a data explosion at the edge. One thing that is common among all these emerging new use cases is that all of them require ultra low latency, high storage capacity, and a high computing power. So let me discuss about the first use case, which is about autonomous driving and connected cars. With increase in computing power, network, and storage capacity, many vehicles will look like a mini data center on wheel. All data generated here will be transmitted over 5G network. Some car could potentially generate data of 5 terabyte to 20 terabyte per day. Next use case is about video surveillance. It is about transmission, storage, and processing of high quality video data, whether it is deployed in home, enterprise stadium, or public cloud. Or a public transport. Let's talk about the sensor that will be deployed in smart factories or a smart grid. Assuming you have 10,000 sensors and each sensor sending 1 kilobyte of reading per second, it translates to 3.6 terabyte data per hour over 5G. Similarly, there are other use cases like telemedicine, online gaming, and factory automation. All of this is going to leave a data explosion at the edge. The role of 5G here is to facilitate offloading data to a local edge site for storage and processing. Let me go to the next slide. So as we discussed, in the previous slide, right? That 5G is going to bring data explosion at the edge. IDC predicts that average person will have nearly 5,000 digital interactions per day by 2025, up from the 700 to 800 what we average today. We also discussed about different use cases in the previous slide, and that is going to generate data at an exponential rate for an edge device. Now the question is, what do we do with all this data at the edge? Like traditional way, we just can't keep storing data at the edge and then later sending it to the core data center for processing and analysis. We need to derive real-time data insight at edge itself. We should have capacity at edge to discard unimportant data. So let me go to the next slide. It will not be wrong to call out that edge is going to become the new core. Gartner predicts that by 2025, 3/4 of enterprise generated data will be created and processed at the edge, which will be outside a traditional centralized data center or a cloud. We need to groom data at the edge itself and be ready to be able to take actionable measures based on user feedback at real time. We should not wait for data, we should not wait for the edge device to be used just for a data storage and the analysis of those data happening later at the core data center. The new use cases requires that you should be able to generate actionable insight at the edge itself. Let me go to the next slide. So let me talk here edge, right? Edge data centers in the context of 5G. In this diagram on the right hand side, what you see in context of 5G is that data goes from end user enterprise device to perhaps enterprise campus edge before making it way to the telco edge cloud and then off to a centralized cloud. For consumer, data goes from mobile phone to telco edge to a centralized cloud. What happens because of data explosion seen at the edge due to 5G? We are talking about billion devices connected through wired and wireless network at edge. One of the things happening with this data is bring cloud-like computing and capability at edge. The cloud native architecture is becoming a de facto way how edge is designed. All deployment services architecture at the edge is influenced by cloud native way of designing. There will be more emphasis on designing microservices based architecture instead of monolithic architecture. Also at the edge, there is growing appreciation that edge network should be designed as an autonomous and an intelligent system. Let me go to the next slide. So this is how we envision that a traditional, or this is how we envision that an edge data center gonna look like. So this is how it all will work, right? So you have all your edge devices like connected car, IoT devices, streaming, cameras, all of us generating huge data, which via 5G lands on edge nodes that will have their local storage. Now you basically categorize data into streams and the traditional object and files based data. And what you would probably need to do is need to process and groom this data at edge itself. You basically be able to have core data center like processing at edge itself. This is where we apply analytics, AI, ML, actionable, groom your data, and provide insight to end devices. What it also does to you is now you have data which is important and data which is not important for you. And data which is not important for you, you can discard or move to secondary storage. Eventually, data that you send to core data center will be lesser but useful one compared to what we have today. You will see that some new kind of tools like Lambda and Kafka kind of architecture, which you can apply to streaming kind of data applications for driving insight. So let me go to the next slide here. So this slide talks about data storage points at edge. So this diagram shows 5 potential data storage points in an edge or distributed cloud topology. From left, which is the far edge devices may not have storage capability. Edge cluster or edge node should have a decent amount of storage capacity for quick analytics and interferencing. Sweet spot is at enterprise edge or a network edge, which could very well be satellite locations, also a mini data centers. It would follow that largest storage locations would reside in cloud region within hybrid cloud model. Let me go to the next slide. So what does it mean for the edge storage? What does it mean for the storage that will be connected to the edge devices? We need to bring in enterprise class processing and action at the edge. One of the example could be using a hyperconverged data interface at the edge. We should have an ability to work with large data sets and apply AI ML model on 5G data. We also need to think about faster storage interfaces. Technology like NVMe gonna become a table stake, right? You can think of taking time of ultra low latency like less than 1 millisecond. That also means you are providing lower cost of ownership and also customized offering for different kind of data. Each of use cases we showed in the previous slides were unique data and different kind of data. So you need to provide customized offering for that. We also talk about in the previous slide about streaming based data, where tools like AWS Lambda, Azure, Google Functions are required for generating data insights. Let me go to the next slide. So today, there are different storage options at the edge. Now, if we talk about cloud native in architecture at the edge, then storage also has to be cloud native designed. And there are a lot of commercial offerings today in the market for the cloud native storage. We have different vendors like Red Hat, Maya Data, Portworx, Robin Systems, NetApp, and HP offering their cloud native storage for the edge. There are some open source projects like Ceph, Longhorn, OpenABS, and Rook also in this area. Let me go to the next slide. So the references that we have taken from is from the white paper 5G at the Edge, the SNIA educational library. For any further questions, you can contact me on umang.kumar@hp.com.